All right, welcome class. So yesterday we talked about how to transform functions vertically. So you should be able to check off your booklet for vertical transformations as well as the practice for vertical transformations. So today we're going to look at how to transform functions horizontally. So transforming functions horizontally are similar to how we do it vertically, but they're a little bit different in the sense that horizontal transformations affect x inside the parentheses. So if you look down here at g, you can see what I mean by that. So f of x equals x squared, this is our parent function. G of x equals x plus 2 squared. Now if you remember, a vertical transformation was like x squared plus 2. So this is how a horizontal transformation is going to look a little bit differently. So if we start with our f of x equals x squared, we can draw that graph because we already know what it looks like. So it's going to look just like this. So we can start filling out our table for that. So we know that negative 3 squared is 9. We know that negative 2 squared is 4. We know that 0 squared is 0. We know that 2 squared is 4. And we know that 3 squared is 9. So when we're doing our g of x, this is a little bit trickier than it was for vertical transformations because we can't just add 2 on to f of x. We have to add the 2 before we square it. So over here, if we have negative 3 plus 2, that's going to equal negative 1. So now we square negative 1, and that's going to equal 1. Similarly, we have negative 2 plus 2, which equals 0. So 0 squared equals 0. We also have 0 plus 2, which is going to equal 2. So 2 squared is 4. We have 2 plus 2, which equals 4. 4 squared is 16. We also have 3 plus 2, which is going to equal 5, and 5 squared is 25. So we can't really graph these points with 25 and 16, but we can graph the ones in the beginning. So if we look, we have our first point is negative 3, 1. We can start plotting that right there. We also have the point negative 2, 0. It's going to be right there. We have the point 0, 4. So we can go ahead and graph that up here. And we can't really graph 2, 16, but we know it's going to be like up there somewhere. So as we have it, it might be a little bit hard to connect this. So I think we should go ahead and look at the point negative x equals negative 1. So if we look over here as we have negative 1 plus 2. That's going to equal 1, and then 1 squared is also going to equal 1. So we can add a point at negative 1, 1. Now if you have started to recognize what the dots look like, you might be able to guess that negative 4 is going to be at negative 4, 4. And you can see, oh, we have another parabola. So we can go ahead and connect that, and it's going to go up like this. Actually, that was bad. Let me draw that again. Sorry. It's going to come down here and then up like that. So it's a parabola, but as we see, it shifted over to the left twice. 1, 2. So when we're adding 2, the parabola is going to the left twice. So sorry about erasing all that, but we can add that answer down here. So did adding 2 move the function to the left or right? It moved it to the left. Now, is that what you would have expected? I don't know. Maybe you would have expected that, but I would think that adding would make it move to the right since the right goes to the positive numbers. But as we can see, oops, it actually moves the parabola to the left. So now let's see what happens when we subtract. So we're going to look at our absolute value function. Ignore that. So we know that our absolute value function looks like a v, so we can go ahead and draw that just so we have our parent function to compare to. So if we fill in for f of x, we know that that's going to become 0. This is going to become 3. That's going to become 4. That's going to become 5. That's going to become 6. So if we start filling out our g of x, this time we're going to have to apply the minus 3 before the absolute value. So we're going to have 0 minus 3 equals negative 3. Absolute value of negative 3 is 3. 3 minus 3 equals 0. Absolute value of that is 0. 4 minus 3 equals 1. Absolute value of that is 1. And then absolute value of 2, absolute value of 3. So we can go ahead and start graphing our points. So we're going to have a point here, this time at 0, 3. We're going to have another point at 3, 0. We're going to have a point at 4 and 1. And we're going to have a point at 5 and 2. And we're going to have a point at 6 and 3. So if we connect these lines, we see here we're going to have a straight line going that way, and over here we're going to have a straight line going this way. So again, we still have our V shape, except this time it's moved over 3 times to the right. So subtracting 3, it moved us to the right by 3. Again, maybe something you wouldn't expect, but it's a little backwards. So subtracting is moving us to the right, adding is moving us to the left. Now let's go ahead and look at one more. This time we're going to look at a situation where we have a horizontal transformation and a vertical transformation. So we're going to look at our parent function, which is x squared, which we know is going to look something like that. Going up and down. So we know 3 squared, that's actually 27. Negative 2 squared, that's actually going to be negative 8. Negative 1 squared is negative 1. 0 squared is 0. And 1 squared is, or 1 cubed is 1. So now doing our g of x, it's a little hard. So first we have to do negative 3 plus 1 equals negative 2. Cube that is going to be negative 8. And then subtract 2, we're at negative 10. Negative 2 plus 1 equals negative 1. And then cube that, we still have negative 1. And then minus 2, so now we're at negative 3. Negative 1 plus 1 equals 0. So we have 0 cubed is 0, and then minus 2, so we're at negative 2. 0 plus 1 equals 1. We cube that, it equals 1. Minus 2, so we're at negative 1. And then 1 plus 1 equals 2. If we cube that, we have 8. And then minus 2 equals 6. So let's go ahead and start trying to graph some of these points here. So we're going to have negative 3 and negative 10, which is probably going to be somewhere down there. We have negative 2 and negative 3, so that's going to be somewhere here. We have negative 1 and negative 2. We have 0 and negative 1. And then we have 1 and 6. So as you can see, we have a situation similar to our other x cubed, where we have our slow change here in the middle, and then it boosts out to the up top and down left. So we can connect that. It's going to come in here and then up there. So if we look at where our vertex is, originally our vertex is here at 0. Now it seems that our vertex is over here at negative 1 and down to negative 2. Which, if we look over here, it seems as if our thing is shifted down 2 and to the left 1. So when we have a horizontal and a vertical transformation, the rules still apply. Subtracting on the outside brings it down by 2, and adding on the inside moves it to the left 1. We just see it moving down and to the left. So Now we know how to move something up and down, to the left and to the right, and doing both. So hopefully you can put it together and work on the practice. So good luck and have a good day.